is doing an experiment. But in math, in our world, we're usually just number crunching, taking measurements. That's not an experiment, right? If we dropped Barbie dolls in stats and did number of rubber bands, distance fell, right? That is actually not an experiment. That's still just observing data. That's a correlation. Okay, to do an experiment, you need to do different tests, hypothesis testing, you make your null hypothesis and such. So what we're going to be doing in here is just making a correlation. And then for this slideshow, I just want to show you, why can't I present? I just want to show you one thing from this slideshow. So regression line, another thing, don't worry about that. That's not what we're going to do. But big thing is, you put a hat on it. In here, we don't worry about as much. But that's because, remember, this is for predictions. Now, be careful. These predictions you make, I think you guys have this page, right? It's on the back of the front. Or it's prediction. So we use it if we have this data for miles driven compared to price of a car, right? We have a chart, and then we want to go post our truck for sale. Or this is what a dealership would do. They have a chart of what they've sold for, correct? So what they do is they legit have an equation. They don't do the equation. Some programmer has, and they type in the year of the truck, the miles driven, all that. Because if you notice, you get a quote for trading the vehicle without even taking it in, right? Because it's just an equation. They plug in all the stuff into a regression line, and it'll tell you how much it's worth, right? Now, does that mean that's how much it's going to sell for? No, but it could go for above or below it, right? It gives you an estimate. So make sure when you are using these lines, so like my truck I drove for 100,000 miles, what do I do with that number? I plug it in, and that will tell me what to expect to get from it, right? Or if you're selling a house, they call it a zestimate, right? You go on there and you see like warehouse, that's a linear regression line. All right, are we good on that? Can you do that in the homework? If I give you a regression line and they say make a prediction based on a certain value? Okay. Now, could I do the other way? If a car costs a certain amount, estimate how many miles it was driven. Could I do that? Yes, I can do that as well. Okay. The only other thing I wanted, there's a vocab term I really want you guys to see. Oh, right here. You need to know this vocab term. It's very important. Extrapolation. So jot that down somewhere. It's important. So if I have a linear regression line and I plug in values outside of my data, that's called extrapolation. Now, extrapolation is a good way to get an idea of what's going on, but it might not be as accurate because you had no data for it, right? So, for example, we do a Barbie bungee jump, and we test with 12 rubber bands, but it takes about 18 to 20 to jump off the cliff. So are we usually extremely accurate when we do it? No, we're close, but we aren't as accurate because that's an extrapolation, right? This works for trucks too, because a truck, if I go to sell a vehicle and there's 300,000 miles on it, it says it's still worth 10 grand. And this was in 2016. So this nowadays actually is not as terrible as an estimate, but at that time, that's a terrible estimate, okay? Because if you looked at the market, they're going for 7, 6 grand. So the 300,000 is an extrapolation because it's far beyond what our data was. I think the highest for our data was like 120. So that's more than double what we had. Just keep that in mind and be careful with that as you go forward with statistics and when you look at things. That extrapolation is a good way to get an idea of what's going on, but doesn't tell you what's going on. Sound good? And that's the end of the day. I do want